Today I'm going to show you how to write concise unit tests. So here I've created a simple class and a method called getFizzBuzzValue. This is a pretty basic method. It kind of does the little fizzbuzz routine. You can pass it a number and it's going to create this result, which is just an empty string. We then check to see if the number that gets passed in is divisible by 3. If it is, we're going to set the result to fizz. We also check then if the number is divisible by 5. If it is, we either then set the string to buzz or append it using the plus equals operator, and then we just return it. So there's 4 potential outputs we could have from this method. We could have just the empty string, in the event that it's not divisible by 3 and it's not divisible by 5. We could have just fizz, we could have just buzz, or we could have fizz buzz. So just off the bat there's 4 unit tests if we wanted to cover all the potential outputs of this. So that's what I have written up here. I've created an Xunit test project, and I've just added 4 unit tests, one for each output that I mentioned. So fizz, buzz, and then the string empty. And these unit tests are very simple. It's a very simple example, but we're going to clean these up and make this more concise by using a theory as opposed to a fact. And this is using Xunit, so if you want to use theories and facts, use Xunit. I know there are probably other options for if you just use like the .NET test suite or any other like NUnit, for example. I don't know if it uses the same things or not. But regardless, so again, these are very simple tests. You do something like we call the fizzbuzzer.getFizzBuzzValue, which was our method. For this example, I just pass it 3. I'm expecting to get fizz. We assert that the expected result fizz is equal to the result that we actually get from getFizzBuzzValue. So I can run all these tests. We'll just open up the Test Explorer. We'll do run. Go ahead and pin that. So all the tests pass. But we can do this in a lot less code, and generally my favorite way to test stuff like this is using theories. So what we'll do is we'll go ahead and we'll start off with our theory attribute, and we'll make another public void, and we'll just call this test 0. So the test is, the way we do this is it's roughly the same as writing a single unit test, so we can kind of copy what we have here and paste it here. But the difference is with a theory, you are going to pass parameters into your unit test as opposed to just having nothing and kind of writing everything out in the body of the test method. So I know what we'll want here is we're going to want our number, and then we're going to want our expected result. And how I pass these parameters in is using the inline data attribute. So we'll add an inline data attribute. So to kind of do what this first test was doing, we will add our number, which was 3, and our expected output, which was fizz. So then we can go ahead and kind of do some formatting here. So we no longer need to write out our expected result. We can just use the expected result that we passed in, which makes that easier. Also, instead of just passing a hard-coded 3, we're going to pass the number parameter. So just off the bat, I can go ahead and run this. So I'll just do a quick Control RT to run the single test, and we can see that it passed. And you can even see here in the Test Explorer that we've got, it shows the number that we passed in and the expected result for that specific test. And so now we can go ahead and add the rest of our tests to kind of clean this up. So I'm just going to go ahead and copy the inline data. Oops, we'll do it. We needed 4. So then down here we have 5, which would give us our buzz, not buzz. And then we could do 15 for our divisible by 3 and divisible by 5. And then we could do something like 1 for our empty string. And you can't do something like, there's some caveats to inline data. Like normally I would just do string.empty, and that's what would get returned, so it would just be something, like that. But you can't put an expression in inline data, and it'll actually, if you try to do that, it'll show you an error And it'll even say an attribute argument must be a constant expression, type of expression, or array creation expression of an attribute parameter type. So for this example, we can't use string.empty. But we know what an empty string looks like. It looks like that. So we can go ahead and use that, and that should pass our test. So I'm going to go ahead and just delete all this. So I went from going from 59 or 60 lines of code, whatever it is, down to 22 to do the exact same test, just in a more concise way. So we'll go ahead and run this again. I'm going to do, we'll go ahead and debug it this time. So I'll throw my breakpoint on there, and I will do Control R, Control T. And I don't think it always necessarily goes in order. It might here. I'm curious if it does. I feel like it doesn't always go in order, but so here we're passing the number 3. So you can see it's passed in. We get fizz, not divisible by 5. We're just returning fizz. And then it'll go through and assert that. It'll work, and then it'll go through the next test. So see, now it's going into the fizzbuzz scenario. So we get fizzbuzz. So it doesn't necessarily run in order. We get our buzz. Results are empty string because we're passing it 1, I'm assuming. Yep. And there we go. And we'll just F5 it, let it finish. And you can see the structure in the test explorer is a bit different. It'll show up as a single test under the fizzbuzzer test class. And then you can expand that and see each individual, test in your theory. But yeah, that's theories in a nutshell and how you can use them to take scenarios where you would have multiple unit tests and just combine them into one. Or if you want to throw a lot of different values just to make sure that you're covering all your bases, theories are a great way to do that. So I hope this helped. Thanks.